Hello everyone, today we from group 1 are going to present the experiment that we have conducted on ART, which is known as electrical resistivity tomography. It is also known as electrical resistivity imaging because we can find the depth of the subsurface and get the perfect visualization on the profile of the ground surface. ERT is a geophysical technique for imaging subsurface structures from electrical resistivity measurements made at the surface using electrodes. It is an advanced geophysics method used to determine the subsurface resistivity distribution by making measurements on the ground surface. ERT measures resistivity, which is measured in ohm meter, and it is the mathematical inverse of conductivity. Resistivity measurements can be made with either an alternating current or direct current. The basic principle of ERT is that the current is induced in the ground using two current electrodes. The electrical potential drop is then read using two other electrodes. A constant current is injected into the ground from the ground resistance tester through the two outer electrodes. The voltage drop resulting from the current flow through the ground is then measured across the inner two electrodes. Most electrodes are designed to provide a direct reading in ohms. The surface electrical resistivity survey works on the principle of potential gradient, which means that the electrical resistivity of soil or rocks and their distribution decides on how the electrical potential in the ground around a current carrying electrode is distributed. The equipments are arranged in a systematic order known as array. So basically there are three types of array. They are dipole-dipole array, Schlumberger array, Venner array. So basically in all this type of array they have geometric factor, which is very important, and geometric factor is a numerical multiplier defined by the geometrical spacing between the electrodes, which is used in conjunction with the voltage to current ratio measured in electrical resistivity surveys to give an apparent resistivity. Firstly, what is the dipole-dipole array? A dipole is a pair of oppositely charged electrodes that are so close together that the electric field seems to form a single electric field rather than a field from two different electric poles. The dipole-dipole array consists of a current electrode pair A and B and a potential electrode, that is pair M and pair N. And it offers a way to plot raw data in order to get an idea of a cross section of the earth. Those using the dipole-dipole array look at a measurement value called apparent resistivity, which represents a weighted average of the resistivities under the four electrodes used to take the reading. The apparent resistivity is typically calculated by a modern instrument from the geometry between the four electrodes and the injected current and measured potential. Secondly, what is Schlumberger array? The Schlumberger array is an array where four electrodes are placed in line around a common midpoint. The two outer electrodes, that is A and B, are current electrodes, and the two inner electrodes, that is M and N, are potential electrodes placed close together. With the Schlumberger array, for each measurement, the current electrodes, that is A and B, are moved outward to a greater separation throughout the survey, while the potential electrodes, that is M and N, stay in the same position until the observed voltage becomes too small to measure. At this point, the potential electrodes M and N are moved outward to a new spacing. As a rule of thumb, the reasonable distance between M and N should be equal or less than 1/5 of the distance between A and B at the beginning. This ratio goes about up to 1/10 to 1/15 depending on the signal strength. So lastly, it is Venner array. The Venner array is the most important array, and we have used Venner array in our experiment. This type of array, that is Venner array, will be explained further by next presenter.
Hello everyone, in this session we are going to talk about Venner array and how to do setup in the field. As we can see from the figure above that the three energizers are connected in series with one energizer connected to the battery. The three energizers are eventually connected to the main system, and the main system is connected via connecting wires to the electrodes. There are two types of electrode where A and B are the current electrode and N and M are the potential electrode. The distance between the electrode is always kept same for this particular array arrangement. Now let us move into the field. In the field, as discussed earlier, we can see that the battery is connected to one of the energizers. The three energizers are then connected in series as seen above. The three energizers are then eventually connected to the system, and the system is then connected to the electrodes. The system is connected through USB with the computer so that the further operations can be done through it. The apparent resistivity of the subsurface is then calculated manually using this formula.
In order to collect the data from the field, we will have to first connect the laptop to the main system and manually input a few information required for the data collection process. When the laptop is connected to the main system using this cable, a letter C will be shown on the left corner of the main system screen, which indicates that the laptop is successfully connected with the main system. After the laptop is connected with the main system, we will have to use the software for manually inputting few of the data that we are going to need for extracting the ART data successfully. Then the software we are going to use is the GAA-RM1. We are going to open this software when we have connected the laptop to the main system. Then we will click on the new table button, and here we will have to enter the data that we require and we will have to upload this data to the main system. The first data is the measure type. Here we will have three options: manual, automatic, and self-potential. In our case, we will be using the manual measure type. I'll click on manual, and second we will have to choose the method or type of method that we are going to use, and in our case we will be using AMNB generic method. The array we are going to use is the Venner array, but the method we are going to use is the AMNB generic method. Then we will have to enter the measure number or the total number of measures that we are going to take, and in our case it is 12. Then we will click on OK, and then we will have to save this table. So when we are done with the ART test, we will get the row R value, which is in ohm, and we will have to manually calculate the row value, which is in ohm meter, and get the required data. Then we will have to save this table. We will save this in, for easy access, we will save this in a desktop, and we will give it a file name. Then the file we are going to save will have to be in a GPD file format. Then we will click OK, and we will have to upload this file to the main system. And after successfully uploading, then we can extract the ART or the resistance value from the field. And after the data from the field has been extracted, then we can again click on this download button to download the data from the main system into the laptop. Now the process of entering the data in the main system will be shown in the next video. In order to take the data from the field, we will have to first do the setup. Then after the setup has been done, we will have to switch on the three energizers, and then we will move to the main system. And from the main system, we will have to first choose the next measure and after choosing it we will click on the enter button here. Then we will click on the execute or the modify button. After choosing the execute or the modify button, we will click on the enter button, and then after that we will again click enter for the execute measure. Then we will click on the confirm button and wait till the data has been processed. Then after the data process has been complete, we will have to check the standard deviation value, which is sigma, and in our case it is 0. If the sigma value is 0, we are going to accept the measure. Click choose the accept measure, click enter, and the first measurement has been complete. After the measurement for the first round has been done, we will have to again switch off the energizer before we remove the setup and move to the next. After we have collected the data in the main system, we have to download that data into a computer or a laptop from the main system, and the downloaded file will be in the form of a GPG file format, and the one which we see just now is the raw data that we have collected from the field. And from this raw data we can get some information like the measurement type, which is manual, and the type of method that we have used to conduct the ERT, that is AMNB generic method in our case, and the total number of measurements that we have taken, which is 12 measures, and the main data that we require from the field is the resistance. And this resistance will be taken into account to calculate the apparent resistivity for the data analysis in the next part. And to calculate the resistivity from the resistance that we get from the field, we will have to apply this formula where rho equals to 2 pi V by I into A, where V by I is the resistance that we get from the field, and A is the unit spacing of the electrodes, or the unit spacing between the two respective or the adjacent electrodes, and here we have rho, which is the resistivity. After manually calculating the resistivity using this formula, we will have to tabulate the required data in the notepad and save it in a DAT file format. Now if I do one manual calculation for resistivity as an example, first we will use this formula, which is 2 and 2 pi. And here we have V by I, which is the resistance that we get from the field, and in our case first resistance that we have is 0.14, so we will enter here 0.14 into, and the unit spacing that we use for the first reading is 5 meters, so we will write 5, and the answer that we get is 4.398 and the manually calculated apparent resistivity that we get is 4.398 So likewise we will calculate all apparent resistivity in a similar case, and after we have successfully calculated all the apparent resistivity for all the 12 measures, then we will end this or terminate this tabulation by entering certain number of zeros, and after that we will save this file and we will use it for the analysis by using another software.
ERT provides an image with the distribution of subsurface resistivity. Based on the resistivities of different subsurface materials or the rocks, the resistivity image can be converted into the subsurface image having different lithologies. Here the interpretation of resistivity result is called or known as the pseudosection. After we are done with manually calculating the resistivity in our notepad, we get the final reading. That final reading needs to be input in our in a RES 2D software to be interpreted, whereby it gives 2D images of subsurface up to a depth of 50 meters. And in order to read the file in the software, we need to first open the RES 2D inversion software, and here we need to click on File. After clicking on File, we need to go to Read Data File. Next, we have to select the location of the file, and we have to select the file which is in DAT file, and we have to open it. Once we open the file, the software will start reading the file, and once it's done, a dialog box will pop out which will indicate that the system has completed reading the file. After reading the file, we have to go to inversion option and then click on carry out inversion. Now we have to rename the file and save it. After this, our result will be displayed, whereby the true resistivity models are presented as color contours sections revealing spatial variations in subsurface resistivity. Here we get a graph of depth versus resistivity in ohm. Through this graph, we can interpret at what depth what type of material is present and how the stratification of these materials are present in the subsurface with the help of the resistivity value, and we can also make out the interpretations based on the color contours.